Muito boa noite, pessoal. Sejam todos bem-vindos. Hoje é mais uma transmissão do canal do UPTV. E hoje trazendo para vocês a nova tentativa então para o lançamento do Falcon 9, né? Aí com a missão Sphere and Punch, né? Lançamento número 27 de 2025. Este lançamento, então, aí vai levar telescópios espaciais, né, com objetivos então de estudos aí na área cosmológica, tá? E esta missão então é da NASA, tá bom? E o horário do lançamento aí está previsto para acontecer à meia-noite e 10 do dia 12 de março, né? Lembrando que ontem nós teríamos, né, o lançamento, mas infelizmente foi cancelada por conta da questão de tempo. Né? Então, aqui um pouquinho mais sobre esta missão, né? Durante a sua missão de 2 anos, o observatório SPHERex, né? Que é o espectro fotométrico, né? E histórico do universo, e a Epoch Reionization and Explore, né? Ele coletará dados sobre mais de 450 milhões de galáxias e mais de 100 milhões de estrelas, né? Para melhorar, então, a compreensão do universo, né, como o universo evoluiu, ao mesmo tempo em que busca moléculas de água e oxigênio. Já os satélites Punch, né, Polarimeter to Unify the Corona and the Heliosphere, né, ou seja, eles vão observar o Sol e seu ambiente para ajudar os cientistas a entender melhor o efeito dos ventos solares em nosso sistema solar. O Sphere, então ele só tem o SPHERex, então só tem apenas né, um item dele. Já o Punch são 4, né? Ao todo, então aí são 5 cargas então que serão lançadas em órbita. E o tempo total de duração desta missão será em torno aí de 52 minutos e 16 segundos. Tá? Lembrando que ainda teremos uma missão Starlink, mas esta missão é, não vou conseguir transmitir ao mesmo tempo, tá? Que esta missão do Sphere. Já estamos ao vivo, então aí vamos acompanhar juntos agora neste momento com a transmissão da NASA SpaceX. Não se esqueça de estar se inscrevendo aqui no canal, comentar e compartilhar. Vamos agora então a nossa transmissão ao vivo. Lembrando, se você puder também aí ajudar na contribuição do canal, basta fazer uma contribuição via Pix aqui para nós. Deixa eu melhorar aqui a qualidade. É bonito. E aqui também. Vou dar uma ajustinho mais aqui na tela. Lá vamos nós. Lembro também de estar se inscrevendo aqui no canal. Lembrando que amanhã, né, por conta do horário também, infelizmente eu não vou conseguir transmitir ao vivo o lançamento tripulado da Crew 10, né, na parte da tarde. Mas, na parte da manhã, no dia 13, né, se tudo ocorrer bem, eu vou transmitir para vocês aí na madrugada, então, aí a chegada dos astronautas na missão Crew 10 na Estação Espacial Internacional. Então, já estamos iniciando a nossa transmissão, vamos curtir juntos aí. Nesse momento não está colocando o áudio, né? Por conta de direitos autorais, mas está explicando aí mais ou menos a missão, que durará 2 anos. Agora, então, aí pelo horário de Brasília, são 23 horas e 16 minutos. No dia 11 de março de 2025.
Live look at the Falcon 9 rocket that's set to launch in just 53 minutes from Vandenberg Space Force Base. This one launch is carrying 2 missions. SPHEREx, a space telescope that will map our cosmos, and Punch, 4 small satellites that will study the sun's outer layer. Hello and welcome to Vandenberg Space Force Base in
Deixa eu só trocar de
California.
tela aqui
I'm
rapidinho.
NASA's Raquel Villanueva, bringing you live coverage from the heart of the spacecraft and launch vehicle operations.
Trocando de tela.
Layer. Hello and welcome to Vandenberg Space Force Base in California. I'm NASA's Raquel Villanueva, bringing you live coverage from the heart of the spacecraft and launch vehicle operations on base. Joining me today is Farah Alibay, SPHEREx Flight Systems Engineer. Thanks for being here, Farah.
I'm so excited to be back with you today.
Well, it's great to have you. NASA's Launch Services Program, also known as LSP, is managing today's launch. And just a few feet away, teams are hard at work preparing for T-0. NASA and SpaceX called off yesterday's Falcon 9 launch of the SPHEREx and Punch
Então, aí
missions
faltando aí
due
menos
to
de
weather and a
52 minutos
SPHEREx
para
ground
o
data
lançamento,
issue.
né? Lembrando que o
That's
lançamento,
right. There was an issue that was
à
found
meia-noite
yesterday
10,
early in
pelo horário
the countdown. It was a communication
Brasília.
issue between the Payload Operations Center that's based at JPL and the ground
Então, vocês
stations
vão
that
ficar
receive the
curtindo aí
data from
rapidinho,
the spacecraft once it's in
né, que eu
orbit.
volto.
The
Pois é.
team at JPL worked all night and all day to find the issue and fix it, and they're now ready for launch. And you know, bumps like that, bumps
Lembrando que o
like that, they
lançamento então é lá em
happen.
Vandenberg,
Space is
na
just
Califórnia.
difficult, and I could not be more proud of the team
Nossa,
that
pra
resolved
vocês.
all of these issues today. And of course, yesterday we were
programa
also really
especial da
worried
NASA
about
com a
clouds. I
SpaceX.
learned so much in the past 48 hours about thick clouds and rocket-induced lightning. I feel like an expert now in clouds.
I could say that you are, and I just want you to know that weather is looking good for tonight. So we are now heading towards a launch that is targeted for 8, 10, 12 p.m. Pacific time. And as you know, Goddard Space Flight Center oversees Punch while JPL manages SPHEREx.
That's right. So SPHEREx is really a partnership of many, many different institutions. We have contributions from Caltech, from BAE Systems that built the spacecraft. That's where we did the integration. We have university partners, international partners, but the whole thing, the management oversight and the systems engineering oversight comes from JPL. And once we launch and we're operating it, the operations center is also at JPL.
Well, Farah, we look forward to your insight tonight. Thank you. And as we continue to monitor important launch milestones, remember there are plenty of ways you can participate in this broadcast.
For one, if you have any questions about anything we're talking about today, send them our way.
That's right. Submit them online using the Ask NASA hashtag, and we will try to answer as many of them as we can live. So, SPHEREx's journey to the launch pad took the space telescope across the western U.S. The observatory was assembled at BAE Systems in Boulder, Colorado. After assembly, it was driven across the Rockies all the way to Vandenberg Space Force Base. Punch was built at the Southwest Research Institute's headquarters in San Antonio, Texas. From there, it was shipped to Vandenberg for comprehensive testing on all 4 satellites. SPHEREx and Punch were then integrated with the launch carrier in a Falcon 9 rocket. Now, let's head over to SpaceX Mission Control in Hawthorne, California, where our team of NASA and SpaceX commentators are standing by.
Good evening, everyone. I'm Jessie Anderson, a senior production manager here at SpaceX. And joining me once again today are Megan Cruz and Mick Waltman from NASA. It's so great to have you both here today.
Yeah, thank you so much for having us again. And I'm really feeling good about launch today.
Yes, it's feeling real good tonight. Right behind us is our factory in Hawthorne, where we build our Falcon 9 rockets and Dragon spacecraft. Countdown to launch began about 7 hours ago. And right now we are targeting liftoff at 8:10 p.m. Pacific Time from Space Launch Complex 4E at Vandenberg Space Force Base.
And I couldn't be more excited to say that right now we are green with weather.
Yes.
The three of us have been keeping an eye on weather all day because going into the launch countdown today, we were concerned about weather, but really it's been trending so much better, Mick.
Yeah, compared to last night, Space Force Launch Weather Officer Lieutenant Park just finished up our weather brief for the launch team. We are looking at less than 10% for tonight's T0. Things are looking great from our thick cloud rule and the way weather's going. Of course, weather is one crucial point of launching rockets, but you mentioned Launch Services Program. That's where we come in. We act as a broker for the spacecraft customer, in this case, JPL, ensuring that missions like SPHEREx and Punch, they get the best possible ride to space. We coordinate with our commercial partners to make sure that everything is happening well. So today we selected SpaceX, and we are looking for a great ride for SPHEREx and Punch to put them in that sun-synchronous orbit to Earth.
Yeah, and we'll talk a little bit more about that orbit during the broadcast. But I do want to point out, you were mentioning that LSP selects the best provider for each mission. LSP has selected SpaceX for 11 launches now.
Yes, and we are so excited for another mission with you all. Over the last 10 years, we've launched incredible NASA science missions that have gone to low Earth orbit and beyond, most recently SWAT, PACE, and Europa Clipper. SpaceX is super excited to help unlock new discoveries in astrophysics and heliophysics with SPHEREx and Punch. And today is actually SpaceX's first rideshare mission with NASA Launch Services.
Yes.
And our next one will be with the Tracers mission, which is scheduled for later this year.
Hey guys, take a look at that live look at the launch pad right there. Not many clouds overhead,
Looks
so
amazing.
that's great.
Looking great, looking great.
Again, the three of us are going to keep an eye on that weather and commentate through the major milestones throughout today's launch. Then next up, we're going to have the NASA Launch Manager poll to see if teams are going to start fueling the Falcon 9. Back to you, Raquel and Farah.
Thank you so much, Megan, Mick, and Jesse. Farah, we have so much to look forward to tonight, including that weather.
Absolutely, and we have lots of guests from both the SPHEREx and the Punch missions that are going to join us today so that we can ask them all sorts of questions.
Exactly, like engineers from the launch will show us how a special orbit helps SPHEREx and Punch by keeping their view of Earth and space consistent every day. Punch principal investigator Craig DeForest will bring 3D replicas of ancient solar petroglyphs we will be able to hold in our hands.
And SPHEREx project scientist Olivier Doré will demonstrate how the Space Telescope maps the universe.
And don't forget the main attraction, the Falcon 9 launch of SPHEREx and Punch. The launch window opens at 8:09:57 p.m. Pacific time. And stay tuned as we gear up for the launch of 2 missions. Now, SPHEREx is loaded with high-tech components to help it map our cosmos. So let's take a look at some of those specs right now. SPHEREx is about the size of a small car and weighs a little less than a grand piano at about 1,100 pounds. It will orbit Earth in a way that keeps the telescope pointed away from our planet and the sun. That helps with infrared observations and also keeps the parts inside cool. SPHEREx will create a map of the entire sky, taking images in every direction, like scanning the inside of a globe. The all-sky map will have 102 different color bands, each a different wavelength of light. This far exceeds the color resolution of previous all-sky maps. SPHEREx will observe over 450 million galaxies with its wide-field telescope. This map will help scientists better understand what happened within the first fractions of a second after the Big Bang. It will also shed new light on how galaxies form and evolve, and where water and ice and other building blocks of life come from. And Farah, we have people from all over the world watching today's launch, and they are sending in some questions. So why don't we get to a few right now?
Let's do it.
All right, coming up, we have Universal Gibson on Instagram who wants to know, how far away in time will SPHEREx be able to observe?
So SPHEREx is creating a 3D map of the universe that's going to help us understand what happened in the first, and wait for it, trillionth of a trillionth of a billionth of a second after the Big Bang. So it's really the very beginning of our universe that we're going to be able to understand with the science that SPHEREx is doing.
Wow, and another question we have coming in, Daniel Burt on Instagram wants to know, how can we see a 14.8 billion year old photon from the universe's start?
Well, so really what SPHEREx is doing is it's taking the current structure of the universe, and actually Olivier Doré is going to come and explain that to us later. But by studying the structure as it is right now, we can sort of hit rewind on it and understand what happened at the very beginning of the universe. But one of the things also is that we're taking images in infrared, and so we'll hear from Phil later about how we passively cool our instruments so that we can be really sensitive to those photons that are coming to us in our detectors.
Oh, fantastic. Thank you so much for answering those questions. We will have more. Keep them coming using the NASA hashtag. We have some punch questions a little later on in the broadcast as well. Now it's time for another check-in on the launch countdown with the team in Hawthorne, California.
Great. Thanks, Raquel. We are just about a minute away from NASA pulling its teams to make sure that we're ready to start loading propellants on Falcon 9.
Yeah, and it's the NASA launch manager, Dr. Denton Gibson. He's the one who's going to be leading the poll. We'll soon hear his voice here. Again, weather, we expected that to be a watch item, but 20 minutes ago we got that weather briefing. Mick, who else are we going to hear reporting out to Dr. Gibson?
Yeah, so NLM will be checking with the teams from the NASA side to make sure that the rocket and the spacecraft look good for launch. He'll be checking with engineering, mission management, safety mission assurance, the spacecraft, of course, and our program to make sure that everybody's good to proceed into propellant loading on the Falcon 9. So we'll get ready for that poll here in about 20 seconds, and we'll hear the NLM poll that team to make sure that we can get into propellant loading.
Again, a beautiful shot of the launch pad at Vandenberg Space Force Base.
Great sunset view. We might get a nice twilight at launch tonight.
Yeah, and there you have it at the top there, the payload fairings with our 5 spacecraft on top. We have SPHEREx, that's 1 spacecraft, and then Punch is comprised of 4, so 5 spacecraft inside the payload fairing there. Again, we're standing by for the NASA Launch Manager poll.
Okay, I'm going to talk as loudly as I can.
A look at the clock, 42 minutes, 8 seconds from liftoff.
And the Punch spacecraft, and I looked back at the link margin analysis, and we do have the backup station.
That's a good copy. And the backup station's HPK is what flight ops was telling me.
Yeah.
Good copy. NASA team, this is NLM on NLMnet, and I'm going to conduct the propellant load and launch readiness poll, starting with NASA CE.
NASA CE, go.
SMA.
SMA is go.
SMD.
Estamos agora, então, na verificação aí do Go no Go para o lançamento. Estamos acompanhando, então, a missão Sphere and Punch da NASA.
NASA MEMS, go.
Lembrando o horário do lançamento, então, às meia-noite,
LSP.
aos 10 minutos, né?
Go.
Dia 12
Circling back
de
to
março de 2025, aí pelo horário de Brasília. Faltando então aí 40 minutos
NLM now.
e 50 para o lançamento.
Copy that. NASA team is ready for propellant load and launch.
Nesse momento, então, agora estamos aí na preparação então para o início do abastecimento Falcon 9 na marca de 35 minutos para o lançamento.
Loading propellant into the Falcon 9.
This is the LD on countdown 1, performing a launch status verification. NLM, are you clear to proceed with the launch auto sequence?
Então aí temos a confirmação então aí para o procedimento então para a sequência de lançamento. Está tudo pronto então para o lançamento, tudo clear.
Ready to launch. The range is green. All great callouts. Again, with that live look of the pad. We are
Boas
targeting
notícias então aí para o lançamento de hoje.
10-12.
Propellant loading. For non-urgent conditions, no-go conditions, brief the CE or LD and they will approve aborting the auto sequence. For urgent issues affecting the safety of the operation, operators shall call hold on the countdown net. Launch control will abort the launch auto sequence immediately and proceed into the launch abort auto sequence. At T-minus 10 seconds, launch control will be hands-off and relying on automated abort criteria for the remainder of the count.
All right, so guys, you're going to notice that we're going to pause whenever we hear out those call-outs on the net, just so that you can have some insight into what we're listening to, and so that you can also follow along with the latest launch updates. For now, let's send it back to Raquel and Farah as we continue with the loading propellant into the Falcon 9.
Thank you so much, Megan, Mick, and Jesse. SPHEREx is set to join NASA's fleet of space telescopes. It will complement the work of more targeted missions by providing a big picture view of the universe. Here to tell us more is Jamie Bach, the principal investigator. Thank you so much for joining us today, Jamie.
Exciting to be here.
You know, SPHEREx is designed to tackle some pretty big cosmic questions. What are some of the biggest mysteries scientists hope to answer?
Well, with SPHEREx, we're using a new capability. We're mapping the entire sky in 102 near-infrared colors, and with that new capability, that lets us address some really fundamental, exciting questions. So the first one is, where's the water? The Earth's oceans are thought to have originated from water in interstellar space in the form of ice. And so SPHEREx is going to map the abundance of water and other organic ices along millions of lines of sight over our galaxy in a way that's never been done before.
No, Jamie.
We're also going to measure the total glow produced by galaxies, and that glow traces all the light made by galaxies over cosmic time from their formation through their evolution. And then finally, we're going to make a giant 3D map of distant galaxies using their positions and distances. And that map, those galaxies trace out structures set up by the Big Bang itself. And so we can use that map to learn more about how the universe began.
That reminded me of another question that we get all the time from viewers. What is the difference between space telescopes like James Webb and SPHEREx?
Well, so imagine you're at Everest Base Camp, and if you have a telephoto lens, like a big telescope like JWST, you can zoom in and see mountaineers on the very summit of the mountain. But if you have SPHEREx, it's like the pano mode on your iPhone. And so with SPHEREx, you get a view of the whole Himalayan range. So those are very different and very complementary ways of looking at the universe.
And Jamie, this is really your baby. I mean, every time we make a technical decision, we always ask ourselves, how do we get Jamie his science? We're here today. How are you feeling?
It really is like having a kid. And SPHEREx was a baby at one point, but it's grown up and it's ready to walk out the door now and make a name for itself. It's both, tense, emotional, and exciting all at the same time.
Fantastic. And where will you be watching launch today?
Oh, I'm going to go outside and look at it in person as it takes off the pad. Totally.
Great.
Wave it goodbye one last time.
Thank you so much for joining us today,
my
Jamie.
pleasure.
We really appreciate you taking the time. So let's head back to the team at Hawthorne.
Thanks, Raquel. Let's take a moment to meet today's vehicle, which is on the pad right there on your screen. Falcon 9 is a two-stage rocket. It is the first and currently the only orbital-class rocket capable of reflight. Starting at the top of the vehicle is the payload fairing, a protective shell that encases the payloads being sent to space today. Now, made up of two halves, the fairing will separate from the vehicle once Falcon 9 has climbed out of Earth's dense lower atmosphere. And today's fairing halves are brand new and will be flying for their first time. They'll be retrieved by our recovery vessel, Go Beyond, after launch. Now, continuing down the vehicle, we have the second stage. The second stage is powered by a single Merlin vacuum or MVAC engine, which is optimized to perform in the vacuum of space. Below that is the first stage, which contains 8 engines arranged around one center engine, all of which are held in place by a structure called the octaweb. Now, each of these 9 Merlin 1D engines delivers about 190,000 pounds of thrust at sea level.
The sequence has started.
Para esse momento
Which gives
começa a
Falcon 9 a
sequência então de
combined
abastecimento
1.7
do
million
Falcon
pounds
9.
of thrust during liftoff. The Falcon 9 first stage is also equipped with 4 landing legs that deploy to allow for a vertical landing on a drone ship or landing pad. And the booster supporting today's mission is flying for its 3rd time tonight, having previously supported NROL 126 and Transporter 12. After stage separation, the first stage will head back to Earth, this time targeting a landing at Landing Zone 4 at Vandenberg. And we should have begun propellant loading. That begins at the T-minus 35 minute mark. So we're about 40 seconds into propellant loading.
All right, Jesse, you mentioned the booster coming back to landing zone 4. That's only about 1,400 feet from where the Falcon 9 will launch from.
Yeah, that is correct, Megan. Being able to launch and land from locations so close to each other makes reusability significantly easier. And in order to do that, after stage separation, the booster has to flip immediately, fire its engines with a boost back burn to start heading the opposite direction, and that it will initially be flying at 17,500 miles per hour to make its way back towards land.
All right, so RP1 is now loading into the Falcon 9's first stage. So we've locked in that T0 for today, 8, 10, 12. We will see you back here in a few minutes when we begin loading propellant into the second stage. Over to you, Raquel and Farah.
Thank you so much. Riding along with SPHEREx is another mission called Punch. It consists of 4 suitcase-sized satellites that weigh about 140 pounds each. They will focus on the sun's outer atmosphere, the corona, and how it generates the solar wind. The spacecraft will also track coronal mass ejections, which are large eruptions of solar material that can drive large space weather events near Earth. The 4 satellites will spread out around the Earth along the day-night line, which enables the constellation to remain in constant sunlight as it creates a continuous, complete view of the corona and solar wind. 3 of the Punch satellites carry an identical wide field imager. The 4th Punch satellite carries a compact coronagraph, which will study the sun's corona and surrounding star field. All 4 cameras will be synchronized in flight so that the science team can combine their images into a 90-degree field of view. Now, Punch will help scientists understand how the sun's energy and particles travel through space and affect Earth. So let's take a closer look at how this is done.
PUNCH is an acronym. It stands for Polarimeter, to unify the corona and heliosphere.
The corona is the outer atmosphere of the sun. It's the part that is no longer gravitationally bound to the sun, and it has so much energy that it flows outwards, filling our solar system, and pushes against the interstellar medium, making a bubble, and that is the heliosphere. And this system of how the corona turns into the heliosphere is what PUNCH is trying to study.
So PUNCH is fundamentally 4 cameras that work together to make composite movies. We have a narrow field imager that views the space close to the sun, and then we have 3 separate wide field imagers, each of which has a large squarish field of view that looks way off to the side, out to 45 degrees away from the sun. That allows us to do something that no other mission has been able to do, which is routinely track coronal mass ejections, space storms, all the way across the solar system as they approach the Earth.
By better understanding these storms and better understanding how they propagate on their way to the Earth, we'll be able to inform our partners on how to better forecast these events in the future. And that's really important for protecting our astronauts, our satellites, and our power grids.
Once we launch and start producing images, you'll be able to look at PUNCH data directly and see the kind of science we're engaged in. You'll be able to see things that are present in the sky right now, and you're not aware of them because they're washed out by the brightness of the sky itself.
We are poised to do tremendous science with Punch because it provides this global context of what is happening in the corona and what is happening throughout the inner solar system so that we can connect the details to the bigger picture.
You might say that Punch is the next chapter in the study of heliophysics as we bring imaging and cross-scale understanding out so that we can develop a coherent understanding of the entire system that starts at the corona and extends out to envelop the planets themselves.
To learn more about the Punch mission, just scan the QR code on your screen or go to science.nasa.gov/mission/punch. And with us now is Peg Luce, Deputy Director of NASA's Heliophysics Division. Great to have you join us.
Oh, I'm so excited. Thank you.
Yeah, let's start with a Punch question. Why are you interested in imaging the solar wind and the outer corona in 3D?
So we are interested in seeing how the charged particles that come from the sun make their way all the way throughout the solar system, especially to Earth. As those particles come to Earth, they can cause aurora, which are beautiful, but they can harm astronauts in space, they can harm satellite electronics, and they can disrupt GPS signals. So by looking in 3D, we can better predict exactly how that space weather is going to reach the wherever we're looking at, the Earth or Mars or wherever we are concerned about where people will be. So it's really helps us improve our predictions.
So it's like the weather prediction that we do here on Earth, but for solar wind.
Yes, it is.
So can you explain to us a little bit how Punch fits into the broader NASA portfolio?
So Punch is going to be part of the heliophysics fleet of satellites. Heliophysics is the study of the sun, the solar wind, and how it affects the entire heliosphere, the entire solar system. So there are different satellites that look at the phenomena close to the sun, and different ones that study how the effects on Earth are done. And Punch will be bridging a gap that we currently don't have in seeing how those solar eruptions actually travel. And we can see them up close at the sun, and we see what's happening once they're far away, but we haven't been able to track them the way Punch will be able to.
Lançamento então do Falcon 9 pela missão SPHEREx and Punch
Can you explain
da
how this
NASA,
is an efficient
né?
approach?
Lá em
So,
Vandenberg, na Califórnia.
For one thing, heliophysics is a
Nesses dias
science that
anteriores, né, como a gente estava
benefits from
acompanhando,
multiple spacecraft flying together.
nós tivemos
And so
aí
we've
esse
been
lançamento
flying
dessa
multiple
missão
spacecraft on the same launch
por
vehicle for a
conta de
long time.
questões
As
climáticas, né,
rockets
aí
have
do
gotten more
local,
capable,
na Califórnia.
we are
Lembrando
more
também
able
que
to
o
fly
pouso
different
do
missions together,
booster
and
do
so
Falcon 9
it's tremendous. It
de
gives us
hoje,
an
né,
ability
será
to
aí feito
maximize the
na
return
zona
on
de
the
pouso
investment in
número
the launch
4
vehicle,
aí
get more
em
science
Vandenberg,
into
na
space
Califórnia. É só
for
vou
the
confirmar
same
aqui.
investment, and it's more complicated,
Ou
but
seja,
it's
então,
absolutely
hoje o
worth it.
pouso será em
Thank
solo,
you
tá?
so much for joining us
Thank
today.
you.
É isso mesmo, na
Oh,
zona
yes,
4, né?
definitely.
Que é a zona de pouso
Now,
número 4.
let's go beyond our
É,
star and peer back in time. SPHEREx is going to investigate some of the biggest questions about the very beginning of our universe. To do that, it will study light so
e aí também é
distant it
isso,
has
né?
taken
Vamos
10
então continuar aí
billion years to reach
acompanhando
Earth. Here's more on what we hope
então
to
aí
learn.
esta missão. Lembrando que este primeiro estágio do Falcon 9 vai ser a terceira missão que ele vai realizar, né? Ele fez missões anteriores com a Norway 106 e a Transporter 12. Tá? E se caso der algum problema, nova oportunidade será dada amanhã, no mesmo horário. Então aí neste momento agora no tempo regressivo, faltando aí 25 minutos e 20 segundos para o lançamento. Para quem está chegando agora, estamos acompanhando ao vivo aí para todo mundo a missão da NASA Sphere and Punch. Da Sphere and Punch, né, são conjuntos aí de satélites observacionais. Né? No caso do Punch, são 4 pequenos satélites que farão então observações aí da parte então, do Sol, né, para estudar mais aí sobre a questão dos ventos solares. E o SPHERex ele vai então aí fazer toda a parte de busca e fotografia aí de galáxias, né, distantes aí do sistema solar, né? E esta missão então tem duração aí de 2 anos, tá? Isso tudo para entender mais aí como foi a constituição e formação do nosso universo. O horário do lançamento, né, para quem está chegando agora, será então aos 10 minutos, no horário de Brasília, aí do dia 12 de março de 2025. Lembrando que ainda, né, hoje também, teremos a missão Starlink do grupo 1221. O horário desse lançamento, que será o lançamento número 28, né, de hoje, será aos 48 minutos no horário de Brasília, também no dia 12 de março. Mas por conta da cobertura especial desta missão, será, então, a princípio, reprisada, né? Então, tá aí para vocês. Vamos continuar curtindo.
John Wisniewski, thank you so much for joining us today.
Não se esqueça de estar se inscrevendo, compartilhando e curtindo
Absolutely.
a nossa
We have heard
transmissão.
about the
Lembrando que cada
benefits of
curtida,
today's
cada vez
rideshare.
mais
So, what
curtidas
does
do
it take for our teams to
nossa
launch these
transmissão
2
tiver, né,
science
mais
missions together?
pessoas
Yeah, so we
podem vir
think
para
about this very
acompanhar
carefully when
a
we're,
nossa transmissão.
seeing whether missions
Lembrando
are
também que quem quiser
appropriate to be
também
ride
contribuir
shares.
com o nosso canal
The
para
first thing
melhoria
we think about is, do they need to go
das
into the same
transmissões.
orbit, into a similar
Temos
orbit?
aí nosso QR
That's kind
Code
of
do
criteria
Pix,
number
né?
one.
Lembrando que o Pix
We also are
só
looking at
funciona
what's the timeline for the development
para
of
quem é
both of
brasileiro,
the
né? Só
potential
funciona no
missions.
Brasil.
We need them to be ready at the same time, right?
Tem móvel
So they
exterior
have
quem é brasileiro.
compatible
Né? Que tem
mass
conta no
and size
Brasil, funciona
requirements
também.
as well, and also technical details like, is one mission going to contaminate another
Olha,
mission?
faltando
and things
22
like that.
minutos
And so in the case of
e
SPHERex and
30
Punch, they
segundos
both
para o
had all
lançamento.
these
Vamos
compatible
acompanhar então
criteria,
toda esta cobertura
and were
especial
good rideshare
até a
partners.
liberação
And we
então
are
dos
really excited
telescópios.
to be able to deliver 2 science missions, with one launch vehicle. It's a great, efficient way to launch 2 science programs at once.
For sure. And so astrophysics it's a really large field with a
Como eu
lot of
falei, a
existential
duração
questions. Can
desta
you talk to us a
missão
little bit about
será
which
então de
piece of the
53
puzzle
minutos
SPHERex is going to be
e
answering?
7 segundos.
Yeah, sure. So in NASA Astrophysics, really our portfolio is answering 3 fundamental themes, right? One is, what is the physics of the cosmos? What are our cosmic origins? And then a really profound question of, are we alone? And it's really cool that SPHERex is touching on all 3 of those themes in some small way. So that was the primary driver of the SPHERex mission. And in addition to that, it's going to be delivering a legacy data set that astronomers are going to be using for literally the next decades to not only answer those questions, but also questions we haven't
E
even
lembrando mais ainda uma vez, né, que o nosso canal aí já ultrapassou a marca de 1.809 inscritos. Quero agradecer aí a todos pelas inscrições.
Again,
Estamos aí
it's
no rumo à
going
marca
after
de
those
2.000
3
inscritos
key
no canal.
themes. Really, they're profound questions.
E eu quero também
How
logo
did we
atingir
get
a
here?
marca
How have
das
galaxies
3.000
evolved over
horas de
time?
visualização, né?
And what was
Essa é
the
arrastando
instance right after the Big
dessa
Bang? And I
forcinha.
think that is really inspiring. It's inspiring to me. I
Assistam
know
os
it's inspiring to the
vídeos,
science
deixam
team.
um like,
I think it's inspiring, to all of our listeners at home
comente
as
o que
well.
quiser.
John, thank
Vou estar
you so
vendo
much
seus
for joining us
comentários.
today.
Thanks. Go SPHERex.
Go SPHERex. NASA has set its sights on deep space exploration, but before that, we're returning to the moon. Here's more with your Artemis Moon Minute.
23 horas e 50 minutos pelo horário de Brasília. Estamos então continuando na transmissão da missão especial da NASA, a SpaceX e Punch. Horário de lançamento aos 10 minutos do dia 12 de março. Lembrando que este lançamento de hoje é o lançamento de número 27 da SpaceX. Caso de em 2025, né? Lançamento 27 em 2025.
Scan the QR code on your screen to learn more about the upcoming Artemis 2 launch and what's planned for our Moon to Mars program. And it's been a busy week on the Moon for NASA's Commercial Lunar Payload Services Initiative, or CLPS, where we've been delivering payloads to the lunar surface ahead of future Artemis missions. On March 2nd, Firefly's Blue Ghost Mission 1 successfully landed on the Moon, carrying 10 NASA science and technology instruments. They are the first commercial company to execute a successful soft landing on the Moon. And Fire, take a look at that beautiful video.
Such a cool video. I think I've seen it 10 times.
And just last week, Intuitive Machines' IM-2 mission achieved a historic feat, the southernmost lunar landing and surface operations ever. Although the IM-2 mission ended prematurely due to the lander's orientation, the data collected will provide invaluable insights into this challenging lunar region. And Farah, how about we answer some more of those SPHERex questions coming in? All right. We have one actually that talks about the launch window and the times that are being heard. Can you explain what 8:10 and 8:09 mean?
Yes, I think we've talked about this a lot, right? So we are trying to target a particular orbit. And in order to do that, we need to launch at a specific time. And we have to launch between 8:09:57 and 8:10:27. So it's that 30-second window in which we can launch. So what we did is we looked at, a few hours ago, we looked at, is there any collision risk? There weren't. And so what the team did is they decided to launch right in the middle of that window. That's really the optimal time to get right on that orbit. And that's why you heard us say that we're launching at 8, 10, and 12 seconds precisely. And that's going to be our launch time today.
Fantastic. And thank you to Luke for that question on Instagram. Luke C on Twitter, on X actually. And we also have Rob V on YouTube who wants to know, how long will it take to map?
So the prime mission for SPHERex is 2 years, and during that time we're going to take 4 full maps of the universe. And so that's really the amount of time that we want to spend, but there is no propellant on board the SPHERex. There's nothing that we're going to, that's going to deplete over time, so we hope that the mission is going to last much longer than that.
Well, thank you so much, Farah. Keep those questions coming using the hashtag. Hashtag AskNASA. With Falcon 9 second stage locks loading about to begin. As you just heard, let's send it back to Megan, Mick, and Jesse.
Welcome back to SpaceX in Hawthorne, California, where Megan, Mick, and I are just outside of Mission Control.
Yeah, and Jesse, SpaceX started fueling its first stage about 20 minutes ago. So how's that looking right now?
Yeah, we're a little bit over halfway done. RP1 loading is already complete on the second stage, and we're just about 80% complete on RP1 for stage 1 and about 60% complete of liquid oxygen loading on stage 1. And we are just about to start loading liquid oxygen on stage 2 at the T-minus 16-minute mark, which we should hear a call out for that in a few seconds.
Again, a great view of the rocket on the pad there. And at the tippy top, we told you that that is the payload fairings. And inside are the spacecrafts, which were encapsulated inside those payload fairings last week.
Yeah, and as Jesse mentioned earlier, talking about the Falcon 9 rocket, those are brand new payload fairings, and SpaceX will retrieve those with their recovery vessel Go Beyond. Inside that payload fairing, we have SPHEREx, our primary mission, which is 1 spacecraft, Punch, which is made up of 4 spacecraft. So deployment tonight, we will see 5 spacecraft deploy into a sun-synchronous orbit.
Now, we were saying that the propellants are RP1 or rocket-grade kerosene and super cold liquid oxygen. You know, why those fuels and how do they launch a rocket?
Yeah, Megan. So RP1 is the fuel component. Liquid oxygen is our oxidizer, which we cool down to make it as dense as possible. Increasing density enables us to load more of it into the vehicle. And with a fuel and an oxidizer, we still need an ignition source. So we use TTEB, or triethyl aluminum and triethyl borane, which combust when combined, lighting our fuel and oxidizer to create that thrust. It's a pretty efficient system that not only gets SPHEREx and Punch into space, but also allows the booster to fly back to Earth and land for another mission.
Yeah, and SPHEREx is going to scan our entire universe to gather data on billions of stars and galaxies, and then Punch. We'll study our sun's corona to better forecast when space weather will affect us on Earth. And Mick, again, you're with NASA's Launch Services Program, which determined that both those missions could fly together on this one launch.
Yeah, as we just heard in a previous interview, we did. We looked at those mission requirements. We assessed the missions, found that both could be delivered to that sun-synchronous polar orbit that we want to get to this evening. The 2 missions sharing a ride on 1 rocket are very efficient, and it also gives us the most availability for our launch opportunities throughout the time period of the science. So again, looking at both of these ride shares, our first one for LSP, we're excited for launch tonight.
Yeah, again, headed to what's called a sun-synchronous polar orbit. And why does that work for both missions? Well, check out my interview with LSP engineers Philip Hargrove and Mark Hemmets.
Okay, Mark, Philip told me to wear yellow today. Why?
Right, so we're going to do a little demo. So you're the sun, that's why you're wearing yellow, and I'm the earth, that's why I'm wearing blue and green, and this hula hoop is going to represent the orbit, or the path that the satellites are going to take around the earth. So we have to pay attention to a lot of things. One of them is the orientation relative to the earth, so that's this inclination, and then also the orientation relative to the sun. So as the earth moves around the sun throughout the year, it's possible that we could be facing away from the sun, we could be facing towards the sun, and for this mission, we want to be facing towards the sun the entire time. So we choose a sun-synchronous orbit so that the twist of the orbit throughout the year is aligned with the Earth's rotation around the sun. So no matter where or when, we're always going to be in this orientation.
Gotcha. So I should always see every part of this orbit.
Yes.
Why is that important for the SPHEREx and Punch missions?
Sure. For SPHEREx, you can't look at the spacecraft without seeing this large cone on top. And that's because this is a photon shield designed to protect the sensitive instrumentation inside. And what it's sensitive to is to the sun. So with the sun always in this direction, that means we know the sun's never on this side. So that's the safe side. So that's when SPHEREx can go ahead and operate in the orbit in this direction, do their celestial sky observations, always working on this backside of the orbit, the safe side. Punch, on the other hand, is the exact opposite. It wants to study the sun. It wants to see the solar wind, the solar weather emanating from the sun coming to Earth. So this is a perfect orbit for them as they go around, because they'll go ahead and get maximum viewing time of the sun.
You know, we've been talking about in the broadcast how Punch is actually made up of 4 satellites, right. SPHEREx is 1. So basically you have 5 spacecraft that you're relatively, you know, near each other as it's going around the Earth. How do you make sure that they don't interfere with one another?
Right, sure. We do a couple things because you're right, that is very important. First thing is SPHEREx is going to go ahead and separate, pointing away from the sun, obviously, so they're going to separate in this direction. After SPHEREx separates, the Falcon's going to do a small altitude lowering maneuver with their attitude control thrusters, just to lower by a couple kilometers, so they're not exactly the same orbit. And then the Punch spacecraft are going to separate in different directions. So the first 2 Punch spacecraft are going to separate equal and opposite along the velocity vector. The other 2 canted off that vector. So that puts them all in different directions, even SPHEREx in different directions, keeping them all safely moving apart from one another.
Because SPHEREx doesn't want to be affected by the sun, can't be affected by the sun. Were there special considerations on the ascent up?
Yeah, absolutely. Again, it's all about protecting the spacecraft and keeping the sun out of this top half. So what we're going to do is, normally we launch out of Vandenberg directly into the orbit plane, but instead we're going to launch east of the orbit plane we want to be in. That puts us on the dark side, or in the shadow, during those early phases of the mission. So as we then come out of shadow, we'll coast down to the South Pole, we'll circularize the orbit in the second burn, and also do a plane change to put us in that sun-synchronous orbit plane we want to be in. So that keeps it safe for the spacecraft.
Guys, I know a lot of work and time went into, you know, all these considerations that you just walked us through. I just really appreciate you guys taking the time to explain it so easily to us. Thank you so much.
You got it. Thank you.
Thanks, Megan. That was a great explanation of the orbit both missions will use. And if you're just joining us, we are approaching 10 minutes until liftoff. Farah, the moment is finally here.
Oh my God, my heart is beating so fast. I'm so excited.
So I know we are going to talk to you more about that in a minute, but we've also been taking your live questions tonight. So let's get to a few more.
Okay,
right?
let's do it.
Okay.
Just distracting me.
I know. We have one from Stardom Observatory on YouTube who asks, how long do you think it will take before we get the first images from SPHEREx?
So today we'll be separating from the launch vehicle. We'll actually get the first bits of data, hopefully very soon after separation. Definitely the team is going to be working through the night. And then we go through a commissioning period. So we'll take a few days to make sure everything is good. Then we'll power on the instrument. So it's going to take a little while, but we hope that commissioning period will take about a month to 6 weeks. And then after that, we'll be moving into the real science. But even during that commissioning period, we'll be getting some images too.
That'll be great to see those first images come in. So keep those questions coming using the hashtag AskNASA. And
agora, pelo horário de Brasília, são 1 minuto. Estamos aí acompanhando a missão SPHEREx e Punch da NASA. Tempo regressivo agora, faltam 9 minutos, 10 segundos para o lançamento. Lançamento em Vandenberg, na Califórnia, aí com Falcon 9. Lançamento então dentro de 9 minutos, mais 10 minutos pelo horário de Brasília. Lembrando o tempo de interação desta missão é de 53 minutos e 7 segundos.
So we have a lot of our team members in this building here at Vandenberg Space Force Base looking at the data, participating in those polls. We have people at the SpaceX building, and we also have part of the team at JPL at the Mission Operations Center, because once we launch, they will be the ones taking over operations, and they'll be working there through the night, taking care of the spacecraft.
All right. Well, Farah, we are now under 9 minutes until liftoff of SPHEREx and Punch on a Falcon 9 rocket here at Vandenberg Space Force Base. Now, let's head over to SpaceX Mission Control in Hawthorne, California, where our team of NASA and SpaceX commentators will count us down to liftoff.
Thanks, Raquel. If you're just joining us, I'm Jessie Anderson, a senior production manager here at SpaceX, and joining me are Megan Cruz and Mick Waltman from NASA.
Thanks, Jessie.
Yeah, the three of us have been commentating through the launch countdown, and we're going to continue to do that for about an hour after liftoff to show teams deploying the SPHEREx and Punch spacecrafts into space.
Yeah, SpaceX started fueling the Falcon 9 at about T-minus 35 minutes, and things are looking really good as we load propellants. We should hear a call out here soon as we get ready for engine chill at about T-minus 7 minutes. Engine chill is where we flow a small amount of that liquid oxygen into the engine to prepare for full flow at the cryogenic temperatures that the Merlin engines will see.
Yeah, exactly. And after that, stage 1 will wrap up RP1 loading around the T-minus 6 minute mark. Then stage 1 liquid oxygen loading will wrap up at T-minus 3 minutes, and stage 2 at T-minus 2 minutes before launch. And we are coming up on that T-minus 7 minute mark that Mick mentioned. Stage 1 engine chill coming up here in a couple seconds. Perfect timing. There's that call out for engine chill.
All right, so the SPHEREx spacecraft will collect a treasure trove of new information about hundreds of millions of celestial objects. And then you have Punch, made up of 4 satellites that will study the sun and how it creates space weather that can significantly impact us on Earth.
Yeah, all 5 spacecraft are packed inside that payload fairing that you see on top of the Falcon 9 rocket. LSP is keeping a close eye on those spacecraft with the spacecraft customer, and they will be transitioning to spacecraft internal power as we complete about T-minus 5.
Stage 1 RP1 load is complete.
All right, there's a call out for stage 1, RP1 load complete. We still have a little more loading left to go. They have to finish loading liquid oxygen into both stages, and there's about another 4 minutes left of that. But again, you know what we're not tracking?
Copy. Spacecraft is on internal power and configured for launch.
Well, that's a good call out there, too. That's Denton Gibson, Dr. Denton Gibson, again, NASA's launch manager, confirming that the spacecraft are on internal power. Can you talk to us a little bit about that, Mick?
Yeah, SPHEREx and Punch on in battery power, getting ready for launch tonight. I'm sure Farah is sitting at the desk just excited for this milestone as the spacecraft are now getting ready for launch later this evening.
And so flying both SPHEREx and Punch on one rocket, I mean, it just saves money. It's a great opportunity.
It's very efficient to be able to take advantage of one rocket and the multiple launch opportunities we can get and get two spacecraft with same science into the same orbit.
Yeah.
And excuse some of those loud sounds. We are actually in the factory here in Hawthorne, so you may hear some work happening behind us. And coming up, a couple things are going to be happening back to back. We have the transporter erector, which is also known as the TE or the strong back. It will start retracting away from the vehicle, and that's that large.
Falcon 9 tanks are pressurizing for strong back retract.
Good call out there. We're pressurizing in preparation for that strong back retraction. Again, that's that transporter erector, that structure there on your screen right next to the vehicle. It provides propellants and electricity to the rocket until just before launch. And we will first begin to see the clamp arms, which are just below the fairing, begin to open up. Once those clamp arms are fully open, then the TE can retract away from the vehicle.
Strong back retract has started.
There's that call out that it has now begun. And so we will see those clamp arms begin to open there on your screen. It'll be very slow and slight. But once again, once they are fully open, then the TE can recline just about a couple degrees away from the vehicle. And there you can see those clamp arms moving.
NLM, this is LD on Countdown Net.
This is NLM.
The NLM providing a status that the Falcon 9 is healthy and we're tracking no issues heading into launch. Can you provide a final verification status for your team?
NASA's go for launch.
Great, thank you.
And a quick poll there. It sounds like we are go for launch. And you can see that transporter erector moving away from the vehicle. It'll be just 2 degrees. And then we can start pressurizing the vehicles coming up here shortly, but propellant is still loading on the vehicles. We're coming up on T-minus 3 minutes where liquid oxygen loading on stage 1 will complete here shortly.
Yeah, Jesse, as we said earlier, this is the third flight of this booster for the Falcon 9 rocket. Those brand new payload fairings that will be retrieved by Go Beyond downrange. Inside those fairings, as we just heard from the NLM, everything is go. The spacecraft are on internal power. Both SPHEREx and Punch are healthy, and we are ready to proceed to launch tonight.
Stage 1 LOX load is complete.
All right, and all that's left now is to finish loading liquid oxygen into the second stage. Again, we're targeting exactly 8, 10, 12 seconds for liftoff here from Vandenberg Space Force Base. Again, a beautiful wide shot right there of the launch pad. We'll stay with you until we deploy both SPHEREx and Punch in a sun-synchronous orbit around Earth. 2 really cool missions. Again, SPHEREx will deploy first starting at about 40 minutes after launch, and then Punch's 4 spacecraft will deploy about 10 minutes after that in 2 batches. Now, as always, we're hoping for some great live views of all those deployments. Next call out we're expecting, again, in less than 10 seconds, that stage 2 LOX loading is complete.
Stage 2 LOX load is complete.
And there's that
Então, nesse momento, o Falcon 9 100% abastecido.
Oxygen loading is now complete, which means that propellant loading is now complete on Falcon 9. That means 1 million pounds of kerosene fuel and liquid oxygen are loaded on the vehicle. And gas closeouts are in work now, and you can see some of those white clouds on your screen. That is us venting out the liquid oxygen lines from the transporter erector, and when that cold gas meets that warmer ambient air, it turns into condensation, almost like what you see when you get condensation on a cold glass of water. We're coming up on T-minus 1 minute where the internal flight computers will take over the launch countdown.
Falcon 9 is in startup.
And there we heard in startup. So next up will be the go from launch director for SpaceX. This means that Falcon 9 will be ready for liftoff. Let's get ready to hear the go from SpaceX launch director for launch tonight.
LD is go for launch.
And there we hear the LD is go for launch, targeting a T0 at 8, 10, 12.
T-minus 30 seconds.
Range is go and weather is go.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Liftoff of the Falcon 9. Go SpaceX, go SphERex, go Punch.
SphERex and Punch on their way to map
Space
out
propulsion is
our
nominal.
universe like never before and revolutionize
Vehicle
space
pitching down
weather
range.
forecasting.
We are T plus 30 seconds into flight, and we are currently firing all 9 of those M1D engines. And after about 50 seconds, we'll begin throttling down those engines, which slow the vehicle down just slightly in order to prepare.
Power telemetry nominal.
In order to prepare for passing through max Q, and that is maximum aerodynamic pressure. That's the largest structural load that the vehicle will see during ascent, so slowing the vehicle down.
Vehicle supersonic.
Slowing the vehicle down will reduce some of the loads that it experiences through max Q. That's coming up here in a few seconds.
Max Q.
Right on time. And now we have a few events that are coming up in quick succession, so we want to lay them out for you really quick. It's going to start with main engine cutoff. That's MECO, and that's when SpaceX shuts down all of its 9 engines on its first stage, which we are getting a great view down the pipe right there. Shortly after that, Stage 1 and 2 will separate from each other, and then seconds later, the first stage will flip back towards Earth, while the second stage will continue on, igniting its MVAC engine. Now that call out is Second Engine Start 1, or SE1, and this burn will last about 6 minutes. After that, the boost back burn on the first stage to put it back on a trajectory towards landing zone 4, which again is back here at Vandenberg, just about 1,400 feet from where Falcon launched from in the first place. Wow, look at that shot. All Merlin engines firing right there, and we have such a great live shot of it.
Main engine cut off.
Stage separation confirmed.
MVAC ignition. Stage 1 boost back startup.
Coming up next, we will see fairing deploy, and that's when the 2 fairing halves will separate and expose SphERex and Punch to the atmosphere of space. SpaceX will attempt, they will actually retrieve those fairings back downrange on Go Beyond once they get back to Earth.
Fairing separation confirmed.
There we hear fairing deployment confirmed, and what you see on the screen is the fairings separating and showing SphERex and Punch on their way to space.
Stage 1 boost back shutdown.
There you see on your screen and heard that call out that the boost back burn is concluding on the first stage vehicle. That's the first of 3 burns that it needs to make its way back down to Earth. This is the 3rd flight for today's first stage, which previously supported 2 other launches, NROL 126 in November of 2024 and Transporter 12 just in January of this year. And you may have noticed some soot on the vehicle prior to launch. During the entry burn, which is coming up here in a couple minutes, Falcon 9 is decelerating by reigniting 3 of the 9 Merlin M1D engines. Now, this causes the vehicle to fly through Merlin's exhaust gases, or the plume, which deposits a layer of soot on the vehicle's surface, and that soot comes from the carbon-based fuel that Falcon 9 uses. With each flight, the soot builds up just a little bit more on the outside of the vehicle, giving Falcon 9 its distinctive reused look.
We're just so lucky to have these great views. Again, we have a split screen here. On the left side is the first stage, and you see those grid fins. They're guiding that first stage back to a trajectory here at Vandenberg Space Force Base. And then on the the right-hand side on your screen, you have the second stage, and you see that MVAC engine is still burning there. Mick, LSP just works really closely with SpaceX to be able to fly reused rockets for NASA missions.
Yeah, Megan, at LSP, we look at all the requirements for all the missions that we have. And as I said earlier, we selected SpaceX for the SPHEREx and Punch mission. And looking at all those requirements, we ensure that even previously flown launch vehicles will meet those requirements, providing NASA with a dependable and a cost-effective ride to space for this, our first rideshare mission.
Yeah, if you're just joining us, hello. We're in your bottom corner right there. I'm NASA's Megan Cruz, and with me is Mick Waltman with NASA, and also Jesse Anderson, a senior production manager at SpaceX. Now, Mick is with NASA's Launch Services Program, which is managing today's launch, so he's going to have a lot of interesting things to say to us to walk us through what we're seeing today. And, of course, we have Jesse from SpaceX. Really great ride so far. We're so lucky to have you guys. LSP chose SpaceX to deliver SPHEREx and Punch to what's called a sun-synchronous orbit 650 kilometers above the Earth. And SPHEREx is going to help answer some of the biggest astrophysical questions out there, like how do galaxies form and evolve, how water and other key ingredients for life came to be. And then Punch is made up of 4 satellites that will study the sun and see how it creates space weather that can significantly impact us on Earth. I mean, Mick, we're talking about issues with GPS or satellites, things like that.
Yeah, it's
Stage 1 entry burn startup.
And there we heard the call for the first stage entry burn startup, looking for entry shutdown here in just a few seconds and getting ready for landing burn in just about a minute.
Stage 1 entry burn shutdown.
There we have Jesse, confirmed engine shutdown for the entry burn. But back to what you were saying, Megan, about the science of the mission. I know Farah is sitting there looking. We are so happy that we got liftoff tonight. But the most important thing about these 2 missions is exactly what you were talking about. Once we get them deployed, the science that they will have to be able to help us here on Earth with some of the things we want. The spectral map of the universe will be incredible. And that solar wind and solar...
Stage 1 FTS has saved.
Flight termination system has been safe.
Stage 1
really
transonic.
And it sounds like stage 1 is on its way back. So that science is very important to us here on Earth. So we're looking forward to getting these deployed this evening.
We do have the landing burn coming up here in a few seconds. That'll be a single engine burn and the last burn that the vehicle needs to land.
Stage 1 landing burn.
There's that call out. Landing burn has begun. Let's watch as Falcon 9 touches down on landing zone 4E.
Stage 1 landing light deploy.
And such an awesome view of Falcon 9 touching down
Stage 1 landing confirmed.
On landing zone 4E, confirming the 3rd landing for this booster.
We had applause here on the factory room floor. It's a fun place to see. It would have been cool to see it at Vandenberg, but this was pretty cool, too.
Yeah, I was going to say I love the launches, but you know what? I love the way SpaceX makes landing look easy,
Stage
too.
2 FTS has saved.
It's still one of my favorite parts, as many times as we've seen it.
And right there on your screen, we lost the signal for a second, but basically we're keeping an eye on the second stage's first burn. That's continuing, and that burn's going to last until just after T plus 8 minutes. And then it will shut down. There will be a coast phase, and then we will relight a second time. All right, so again, first burn out of the way. We will see a second burn later. That's going to happen around T plus 39 minutes. We hope that you stay with us to see the deployment of both SPHEREx and Punch. But for now, we're going to send it back to Raquel and Farah, because I know Farah is probably cheering right now.
Yes, absolutely.
You are correct. Absolutely. If you're just joining us, I'm NASA's Raquel Villanueva, joined by Farah Alibay, bringing you live launch coverage from Vandenberg Space Force Base along the central coast of California. And just over 9 minutes ago at 8:10 p.m. Pacific time, we watched as a SpaceX Falcon 9 rocket lifted off. And Farah, I think that is the happiest you've ever been, and I've known you for years.
Oh, yeah. I mean, I'm so happy that we're finally in space. And of course, we still have to get through separation. But oh my gosh, being in this building, everything was shaking. But Mick will be jealous because really that sonic boom as it was landing, it caught me by surprise. It was very loud.
It shook the entire building we were in right now. How does it feel now to have it off the ground?
We still have, a good 30 minutes to go before we separate. So we still have to hold on for that. But it feels really great to have SPHEREx in space. We saw a peak at the photon shields when the fairing separated, and I saw she was all in one piece, so we're good to go.
Fantastic. The rocket is flying 2 important missions today. One is your SPHEREx, a space telescope that will create the most colorful 3D map of the cosmos ever, and Punch, 4 small satellites that will study how the sun's outer atmosphere turns into the solar wind that fills our solar system. So I have a little pop quiz for you, Farah. Do you know what each of those missions stand for? Let's start with yours.
SPHEREx is the Spectro-Photometer for the history of the universe, Epoch of Reionization, and ISIS. Oh my gosh, I'm ISIS Explorer.
Got it, yes. It was a close one, but you got it. And now how about Punch?
It's the Polarimeter to unify the corona and the Heliosphere. That one's easy.
Well, great. That was an A+ for you there. Before its journey in space, SPHEREx had to go comprehensive testing. Farah was there for the whole process and will give us a behind-the-scenes look.
Acompanhando então a missão SPHEREx em Punch. Dentro de instantes, teremos também a missão Starlink, do grupo 1221. Aparentemente, então, dá para a gente transmitir ao mesmo tempo a missão também do Starlink, tá? Por conta do horário do lançamento, que é agora às meia-noite e 48, mais 48 minutos, né, do dia 12, né? Isso se não tiver alterado o horário do lançamento, a gente também pode fazer a transmissão aí da missão Starlink, tá? Ao mesmo tempo para vocês, como já aconteceu antes, né? Já fez então essas transmissões antes, né, anteriormente. A transmissão aí para a missão Starlink começa então dentro de instantes, aos 42 minutos, né? Enquanto isso, a gente segue então acompanhando aí a missão Sphere and Punch da NASA, tá? Lembrando que mais ou menos então dentro de quase 40 minutos do tempo percorrido, teremos aí então a live sem comentário, né? Daqui a pouco, né? Porque daqui a pouco então aí vamos ter depois o segundo ponto de ignição. Deixa eu ver aqui como é que vai ficar a nossa cronograma. Agora após o primeiro ponto de ignição, né? Então vamos lá. Então, aqui, o segundo ponto de ignição só vai ser dado na marca de 39 minutos e 28 segundos. Né? E aí, depois, teremos a sequência de liberação das cargas aos 41 minutos e 56 segundos. Neste tempo, dá para a gente acompanhar a missão Starlink, né, como já aconteceu uma vez, né, que a gente estava acompanhando junto com a missão da Rocket Lab, né, quem lembra, né? Foi a Rocket Lab junto com a Starlink, né? Né? Enquanto ela estava viajando, Quick Stage, né? Nós transmitimos juntos a missão Starlink, né? Então, dessa vez também será o mesmo. Né? Até o momento, então, não mudou de horário o Starlink. O Starlink continua aí no mesmo horário. E vamos seguir acompanhando, então, esta missão.
Off tonight, and this moment is so meaningful for the SPHERex team and the institution of JPL. This year began with devastating wildfires across the Los Angeles area, including the Eaton fire that burned dangerously close to JPL. And Farah, hundreds of employees were impacted.
Yes, including members of our very own SPHERex team. Some were forced to evacuate, and unfortunately, others lost their homes. And it all happened right as we were preparing to ship the SPHERex Observatory from Boulder, Colorado to Vandenberg Space Force Base. Many of us were right in the middle of final shipment preparations when evacuation orders started rolling in. We even had to change our transport route to avoid fires, heavy smoke, and road closures, something none of us had ever expected to have to plan for.
You know, and throughout the firefighting effort, JPL provided water resources and a helicopter landing area for firefighters. First responders and our community went above and beyond, helping those in need and working tirelessly to protect JPL and nearby homes. And we would like to thank them for their courage, dedication, and support.
Yeah, I think this is exactly the time when our community really shines, and we're so thankful for them.
Absolutely. You know, and someone else we'd like to thank today is the director of NASA's Jet Propulsion Laboratory, Lori Leshin, and she joins us now. Lori, it is so great to have you here.
Go SPHERex! It's so exciting, and thank you for that wonderful opening about our first responders and our whole brave community. It's really special.
Absolutely. And Lori, this launch is a true bright spot for JPL's family. How are you feeling after watching that launch?
You know what? It's such the culmination of the hard work of so many people over many, many years. And even up towards the end, we have had quite a launch campaign here with lots of stops and starts. And when you're outside and are able to see that rocket go up, and this one, it flew right through Orion's belt. Oh, gorgeous. It just makes it all worth it.
Yeah, you could feel the rumble here too.
Oh my gosh.
And you know, SPHERex is a great example of a smaller, more focused mission with incredibly ambitious goals. How do missions like these fit into the bigger picture of what JPL does?
Well, at JPL, we're really all about cutting edge science, no matter what size the spacecraft it is, right? We do big science with big missions like Europa Clipper and the Perseverance rover, but, and SPHERex is an example of doing really big science in a somewhat smaller mission. And so it's just great to see when there's the right kind of science question, we build the mission to answer it.
And SPHERex is also a collaboration between multiple partners. Can you explain to us how that led to the mission success and maybe how that might influence future collaborations?
Absolutely. I always say, cosmic teamwork makes the dream work here, right? So collaboration is key to everything we do, whether it's with universities across the country and around the world, like we've done on SPHERex. We have international partner Korea involved in the SPHERex mission, and of course our industry partner at BAE Systems and the PI at Caltech. So it really is taking the best from lots of different organizations, and that's why our motto is Dare Mighty Things Together, because everything we do is about the team.
Well, thank you so much for joining us today, Lori. We appreciate having you here with us. Launch is really just the beginning for the SPHERex team. Right now, mission control is kicking into high gear at JPL. For a sneak peek at what's happening behind the scenes, I caught up with the project manager and flight director for SPHERex. Can you describe why this space is so critical to the mission?
Well, this room, the Earth orbit
and I have seen far a snack on them all the way here.
Definitely, we need a little bit more of that good luck for separation coming up.
I'll take us through separation. And now let's send it back to Jesse Anderson in Hawthorne with a look at SpaceX's history of supporting the next generation of space exploration with NASA.
It's incredible having the opportunity to support NASA science missions to space, just like today's mission. In fact, last month was the 10th anniversary of the very first mission Falcon 9 and SpaceX launched for NASA, the Discover Space Weather mission, which launched in February of 2015, which you can see there on your screen. Since first taking flight in 2010, Falcon 9 and Falcon Heavy have completed more than 450 launches and more than 380 reflights. As the first orbital-class rocket capable of reflight, Falcon 9 has helped drive down launch costs while increasing flight cadence, making space more accessible for all types of missions. Falcon is helping NASA build our future in space through contracts like the Commercial Lunar Payload Services Initiative and agreements like the one behind today's mission, the NASA Launch Services 2 contract. SpaceX is enabling access to space at a cost and cadence that no other vehicle flying today can match, unlocking a wide array of new government, commercial, and scientific opportunities in space. Before Falcon 9, launching to space was infrequent and cost much more than it does today. Lowering the cost of access to space is the foundation for humanity's next steps into the solar system. More launches accelerate development, enabling more small satellite and private research customers to launch their work to space, which in turn helps stimulate the wider space economy here on Earth. And serving both cargo and human spaceflight missions, Dragon has visited the International Space Station 45 times. In addition to NASA's crew missions, Falcon 9 and Dragon are advancing human spaceflight through private astronaut missions as well, including the Axiom missions Inspiration 4, Polaris Dawn, and our upcoming From 2 mission. And missions like SpaceX's Transporter and Bandwagon rideshare programs help make access to space even more affordable by sharing the cost of a single launch across multiple customers. All of this to say, reusability is the key innovation that is making space more accessible. Now, we are T plus 23 minutes into today's mission, and in a few minutes, in about 15 minutes or so, we will be reigniting that second stage to continue the journey with SPHEREx and Punch. We'll send it back to Raquel.
Thank you, Jesse. Punch, along with students from the Unify, Colorado Boulder, are bringing ancient solar observations to life. Their project, Solar Stones, transforms historic petroglyphs into art. Let's take a look at how it's connecting the past to modern science.
Daqui a pouco, então, iremos acompanhar aí a missão Starlink, hein? Fiquem de olho. De instantes, então aí iremos mudar a nossa transmissão então para a missão Starlink. Será em destaque para vocês.
Well, those solar stones are so cool, and with us now is Punch Principal Investigator Craig DeForest. So glad you could join us, Craig.
Thank you for having me.
And I see you brought some examples with you today.
I did indeed. So Punch is studying the sun, astrophysics at home, right around us. And in that, we're carrying on a tradition that goes all the way back to the ancients. So this is a 3D printed representation of what may be the oldest representation of the solar corona in a durable medium. This was recorded life-size, it's this large. Somebody about 1,000 years ago chipped this into the rock right near what is now the visitor center at Chaco Canyon. And this is consistent with, and many believe it to be, a representation of the solar eclipse of 1097, which occurred over Chaco Canyon. People actually witnessed it and observed the corona around us. So that ties us from the ancients to the modern esoterica of spaceflight.
And why was it important for Chaco Canyon to be the location for the Punch mission solar stones?
So we organized our outreach program around ancient and modern sun watching, and Chaco was a large center of culture about 1,000 years ago. The folks who lived here at that time had a long history of science, the technology that they had in hand, and of observing the sun around them to predict their environment and their future in much the same way that we do today. Though of course they were looking for things like agricultural planting times and things like that. But that thread of human curiosity looking at the environment around us extends all the way to what we do at NASA today.
So speaking of what we do at NASA today, so Punch has a coronagraph that sort of mimics a solar eclipse, right? And that allows us to study the corona. Can you explain how that works?
Certainly. So normally we can't see the sun's corona or the much fainter solar wind that Punch will image. And the reason for that is the sky is too bright. The sun is very bright in the sky is very bright. We normally can't see the corona unless the moon blocks the sun out. When we're standing in the shadow of the moon, we can see around the planetoid to see the solar corona extending out into space. But that doesn't stop. That extends all the way out and washes over the Earth. So Punch is in space. We can, instead of the moon, apply a very carefully crafted piece of metal to cast a shadow on our camera and allow us to see the corona 24/7 around the clock.
Wow. And we really appreciate your expertise. We have some Punch questions coming in for viewers. Do you mind if we answer a few right now?
Let's do it.
All right, let's see what we have here. We have Rosanelle Acosta on YouTube wants to know, how does the satellite improve our ability to predict phenomena such as solar storms and their impact on Earth?
So Punch will allow us to forecast space weather much better than we can now. Right now, we look at the space near the sun, the corona, and observe storms forming and leaving the sun. They streak out across the solar system at 1,000,000 miles an hour or more. And then we extrapolate all the way across the void to our planet. We don't have a way of measuring them in transit. So with Punch, we'll be able to track them in 3D as they make the entire journey to the Earth. So that's very similar to what we see if you saw the weather report earlier. We always look at those geosynchronous images of the Earth to track weather storms as they cross the face of the planet. We hope to do the same type of thing for...
Bem, nós agora vamos trocar de tela rapidamente, para a gente acompanhar agora a missão Starlink do grupo 1221. Na sequência, voltaremos então com a transmissão da missão Sphere and Punch, com a missão, parte final então aí desta missão. Então vamos seguir aí então a nosso cronograma. Vamos ver, se primeiro tivemos alteração no horário. Sim, tivemos alteração no horário. Foi para o dia 12 de março, então a missão Starlink 1221. Então vamos seguir acompanhando então a missão Sphere and Punch, que foi alterado então o horário da missão Starlink.
Welcome back to SpaceX in Hawthorne, California. Megan, Mick, and I are just outside of Mission Control, where teams continue to monitor Falcon 9's second stage.
And we have a view here that we're looking at, and we're seeing that stage 2 is currently coasting near Antarctica right now. So where it needs to be, we are loving the trajectory and seeing the data that we're getting back. The Falcon 9 lifted off of Vandenberg Space Force Base about 31 minutes ago. It's carrying 2 NASA science missions, SPHEREx and Punch, and both are headed to a sun-synchronous orbit around 650 kilometers above the Earth.
Yeah, and what does that mean for us? That means that we will be passing over the same part of the Earth at roughly the same local solar time each day. That means that the lighting conditions are consistent for observations, which is important to SPHEREx and Punch. For SPHEREx, that provides a consistent illumination condition, reducing background noise from the varying sun angles. And for Punch, it keeps them in a fixed Sun-Earth viewing geometry, crucial for tracking the solar wind's continuous evolution. In short, this orbit allows both missions to maximize their scientific observations with minimal interference from the Earth's shadow.
Yeah, basically, SPHEREx likes the sun and Punch does not like the sun. So they're really riding
That's another way to say it.
So they're really riding that day-night line, and it's just perfect. You know, that's why, again, we're flying these 2 missions together. So, again, we're going to gather some really, really great science. SPHEREx is going to map our entire universe to gather data on billions of stars and galaxies, and then Punch is going to study our sun to really better forecast space weather and how it affects us.
Yeah, and the second stage with SPHEREx and Punch will coast for another about 7 more minutes before we have another ignition of the MVAC engine. And then following that, we will deploy SPHEREx first and then Punch's 4 spacecraft. As always, we're planning to have live views of each of those deployments starting at T+40 minutes.
Yes, we can't wait. So we'll see you back here soon. For now, let's send it back to the hostess at Vandenberg Space Force Base with Raquel and Farah.
Thank you so much. Turning our attention back to SPHEREx, the Space Telescope is gearing up to map the entire sky like never before. With special photon shields and an ultra-cool design, here's how it will spot hidden cosmic secrets in infrared light.
This is SPHEREx, NASA's cosmic mapmaker. It will scan the entire sky, charting the positions of hundreds of millions of galaxies. But why does it look like my dog after his last visit to the vet?
These concentric cones help keep SPHEREx cool and shielded from nearby bright objects. Anyway, continue.
Ah, of course. SPHEREx has 3 cones, which are called photon shields. They block light and heat from the sun and the Earth. That's a big deal because without those shields, the telescope's detectors would be blinded. But SPHEREx also needs to be cold because it detects infrared light, or wavelengths slightly longer than what the human eye can see. Infrared is emitted by warm objects on Earth and out in the universe. It's also emitted by the telescope. Keeping it cold reduces the infrared glow, which lets SPHEREx see faint objects that are really, really far away.
That's right. These aren't cones of shame. They're SPHEREx's cones of fame. Here you can see one of SPHEREx's 3 cones being assembled. They sit atop this shiny jewel of a structure called a V-groove radiator. The mirrored surface directs heat out into space, cooling the telescope and the infrared detectors.
Cooling them to minus 350 degrees Fahrenheit. That is cold.
SPHEREx can help us study everything from what happened a few seconds after the Big Bang to where water comes from in planetary systems. That's why its full name is Spectro-Photometer for History of the Universe, Epoch of Reionization, and ICES Explorer.
And I'm sorry, could you say that one more time?
You can just keep calling it SPHEREx.
And so I will. The V-groove radiator and the photon shields surround the heart of SPHEREx, the telescope. It's a feat of modern engineering, designed with incredible precision. And it looks tilted?
That's not a mistake. That tilt helps it see the entire sky while under the protection of the photon shield. Do you mind if I get back to work?
Sure, let's wrap this up. The cone of fame, the gorgeous jewel, the tilted telescope. These are all part of NASA's next cosmic mapmaker, SPHEREx.
That passive cooling is really incredible.
Absolutely. And actually, SPHERex instrument scientist Phil Korngut joins us to talk about that cooling process. Yeah. Thanks for being here, Phil.
Yeah, thanks. So exciting. So indeed, yes, SPHERex uses a totally passive cooling process. That means we have no refrigerators, we have no liquid cryogens or anything like that, and we use actually the coldness of deep, dark space to bring the temperature of our instrument down. And to show you how that works, we made a little demo here. This is a little thermal model of SPHERex, and you can see it's got its three, iconic photon shields. And then inside there, you can see that we've got a model of the telescope and the focal plane radiator. So back in Pasadena, we took this thing to do a little demonstration to show you how that might work. So we put it up on the roof of the Cahill Building for Astrophysics, which is actually the building that we assembled the SPHERex instrument in. And we put it up there with a great view of the night sky. So there's thermal engineer Brad Moore and I getting everything set up. And the point is that using that night sky, even here on Earth, we can cool it down. So here in this time lapse, as we left it out there overnight, you can see why this is harder on the Earth. Those clouds up there, the atmosphere is actually pretty dark in the infrared. Not to mention that air makes conductive heating between the Earth and the radiator. You can see also there we left the camera in the foreground. That's actually an infrared camera, so you can see what's happening with the heat glowing off of the telescope inside. So you can see here, as we look in the infrared, there's a lot of light coming off of that telescope because it's warm. And as the time lapse goes on, you see that light coming down, that glow that's coming off the infrared as it dumps out to deep space. If you look to the outside of this, there's a glow around the photon shields, and that's from the Earth coming up. And so inside, it looks dark because it's reflecting the cold sky from the photon shields. And as we go on, you can see that light comes down, and our telescope is getting cooler. So the next morning, we come in and see what happened to our experiment. There's Brad and I coming in. You can see the glow from our hot coffee. This is an infrared video, so you see all the light that's actually glowing off of us at room temperature. Here we are looking in there to see what we found, and that's what it looks like. That radiator was nice and frosty. You can see when I swipe my finger across it, there's all that dew on there, and that's because we cool down using passive cooling below the dew point, and we condensed water, and we made a little frost on the outside, and we did some passive cooling on Earth.
Well, Phil, that's actually what my car looked like this morning with the windshield wipers filled with dew.
That's right, and that's actually passive cooling. And I bet you, if you looked at where your car was parked, it's actually had a great view of the sky. And if you maybe parked under, like a garage lid or a tree or something, you wouldn't have that because it didn't get to passively cool.
And so SPHERex is going to use that passive cooling to detect those super faint galaxies, right?
That's right, yeah. And so as you saw in that video, which was in infrared, warm things are actually glowing like crazy. So we're trying to detect, light that comes from tiny blips of these galaxies all the way across on the other side of the universe. So in order to get there, we have to cool down the foreground because all that light is just swamping us, and we've got to get the light from the telescope glowing down so we can see those tiny blips across the universe.
Right. Well, Phil, thank you so much for joining us. Now let's head back to the team in Hawthorne, California for a status update.
All right, we're now 39 minutes into the mission, and coming up is what's called SES-2, and that's when SpaceX will reignite its second stage engine, which you see right on your screen there.
Yeah, we are expecting that SES-2, this is the second burn for this mission to ignite. There it is, right on time. You can see that there on your screen. Now this is about a 50-second burn for this burn. And this extra burn, this is a single Merlin vacuum engine, has about 220,500 pounds of thrust. And burning just for about 50 seconds doesn't seem like much, but it's just enough to take the second stage with the payloads attached to its targeted drop-off orbit.
That's exactly right, Jesse. This burn will put SPHERex and Punch exactly where we need to be, getting ready for SPHERex deployment. An exciting time. I know Farah is looking forward to that one. So are we, but things continue to look good.
And there you can see on your screen that the MVAC engine is now shutting down.
Nominal orbit insertion.
And you know, the second burn is actually a lot earlier than in other missions because, again, SPHEREx has to avoid the sun even on its way up to that sun synchronous orbit.
Yeah, as Mark Hammonds mentioned earlier, the earlier second burn is a planned burn to ensure that SPHEREx maintains that sun avoidance while achieving its intended orbit, and we heard nominal insertion there. This timing helps prevent the exposure to excessive solar radiation, keeps our thermal conditions that we just heard about within our limits, and ensures that proper instrumentation performance on the spacecraft getting ready for this trajectory and separation.
And we did have a confirmation of second engine cutoff as well as good orbital insertion, as Mick called out there. And we are coming up in a few minutes. We will have, actually in about 30 seconds, we will have payload deploy of SPHEREx. We've got some great live views there on your screen. Earth looks amazing there.
That is a really great view. And we're glad to have it. Again, we're expecting that deploy at 41:56, about there. SPHEREx was designed to operate for at least 2 years, but the team says if all goes well, it could operate much longer.
Expecting deployment here in just a few
SPHEREx
seconds.
separation confirmed.
And there we heard the call out, and now you can see that there on your screen. SPHEREx is drifting away from Falcon 9's second stage, confirming deployment.
Woohoo! It took everything in me not to talk over you and go, yay!
So exciting.
Are you kidding? Farah is at the hostess right now, jumping up and down.
I'm sure.
Yeah.
Yeah, again, great live views. It's always nice to see. And again, this is a great opportunity for the spacecraft team to see it happen in real time. So now the spacecraft has a 3-minute pass over a ground station in Antarctica. You might have heard it mentioned a couple of times in the broadcast. Troll is what that ground station is called. And the team hopes to confirm an initial signal with the spacecraft.
Yeah, that initial signal will primarily be gathering engineering data for its health and status at this time. And once they confirm that and that it's ready to be operational, SPHEREx will then transition into its science phase, starting with calibration and test observations over the next few days or weeks that Farah had mentioned, and another pass over another ground station in Norway at about T plus 80 minutes. So about 40 minutes from now, they will start working on that and confirm that everything looks great on SPHEREx. So we're just waiting to hear that initial engineering data check from on AOS for SPHEREx, where they start receiving that engineering data just to make sure everything is good there at Troll.
Those iconic cones around the spacecraft, again, you can still make it out as it gets farther and farther from the second stage. But actually, let's take a look inside the Mission Directors Center. So that is one of the rooms that we have at Vandenberg Space Force Base. And sitting inside there, we have NASA personnel, but we also have SPHEREx and Punch personnel. Actually, if you look at the front row of your screen, directly to the right of the aisle, that is Jamie Bach, and he's the principal investigator for SPHEREx. I don't know about you guys, but I'm going to be looking at him for a reaction.
I don't know. I'm going to be looking at that whole room. I think they're going to be just as excited as everybody.
He waved. I think he heard us. You're watching. We're watching him. He's watching us.
Yeah, we're waiting for that initial AOS for that engineering checkout, and that team in the Mission Director Center there at 836 at Vandenberg Space Force Base, I know is excited to see this deployment also.
Yeah, and he's in that first row. He's joined by some more spacecraft team members, as well as from some leadership at JPL. So really glad to just see the whole team there, waiting for again this important milestone. Again, we have this 5-minute or this 3-minute pass with this ground station. So anywhere in this time, if we're able to get a hi, hello, quick acquisition of signal, that would be a great sign for the team. And then those subsequent passes over different ground stations, again, Norway as well as Antarctica, or no, Alaska, Fairbanks, Alaska, will give them an opportunity to get even more information and more data from the spacecraft.
Beautiful views from second stage there. Second stage performed very well tonight. Still continuing its mission with that second burn. We still have Punch on board, and things looking great there as second stage continues to coast.
Yeah, Mick, some of my favorite things about launch is really the views from space that you don't get to see from down here, but we get to see it from the spacecraft out in space during these missions. And these were some incredible views tonight.
Yeah, it really puts into perspective, what we're doing here. We are sending spacecraft that do incredible science out into an orbit around the Earth, and all the data that's collected, this is science that touches all different kinds of disciplines. Specifically for SPHEREx, right, it's again, just being able to see and map our universe in a way that we've never done it before. It's going to really answer some of astrophysics' biggest questions. And then for Punch, studying our sun and understanding how it can affect us in terms of space weather, comms going down, telecommunications, satellites, things like that, all affected by space weather. So Punch is really going to help us understand how to better predict when space weather might affect us.
And it looked like we did lose acquisition of signal from the second stage, but the mission isn't over yet. Falcon 9 second stage is still carrying NASA's Punch mission, 4 satellites that will study our sun's corona. And those will start deploying around 52 minutes after launch. So be sure to stick around for that just a few minutes from now.
Thank you so much, Megan, Mick, and Jesse. And Farah, what is next for SPHEREx?
So, of course, we would have liked to hear it from it right now, but this, it's a very short pass, as you heard, and so the SPHEREx is continuing to orbit around the Earth. It's getting itself into the right configuration. It's going to go over another ground station called Svalbard up in Norway in about 40 minutes, so we'll hopefully hear from it then. And so we'll be anxiously waiting to hear from her and to tell us that she's doing well in space.
Well, thank you so much for that update, Farah. And joining us now is project scientist Olivier Doré. Olivier, thank you so much for joining us.
Pleasure.
So Olivier, tell us, SPHEREx is taking a 3D map of the universe, right? How and why is it doing that?
Yeah, that's a very good question. Thanks, Farah. And this question is really at the core of SPHEREx mission goals and also its design. So let me start with the why. And to explain you the why, I will use this crystal ball here. And don't worry, I'll use a crystal ball to explain the past and not to predict the future. So, but if you look closely at this crystal ball here, what you see inside, you see all kind of small filamentary structures, elongated structures that connect and intersect. Some kind of three-dimensional spider web. So this turned out to be a really good visualization or representation of how galaxies are distributed throughout the universe. And in fact, we call that the cosmic web. So what SPHEREx wants to do is make a three-dimensional map of the cosmic web over the whole sky. And the reason we want to do that is simply the fact that by making this map of the cosmic web over the whole sky, we can get very unique insight about the very first moment of the universe, when the universe was only a fraction of a second old. So that's really what we want to do. And so to get to the first part of your question, how, so that we will do that by really mapping the whole sky in 102 colors. And so why do we want to use colors? It's very simple. So if you look at the sky, take a picture, you will see that you know exactly where stars and galaxies are. But if you want to know how far they are from you, if you really want to measure the third dimension, you need to use the color information. By using colors, you can really tell how far a galaxy is from. You can really tell the distance between you and a galaxy. And so you can construct, if you map the whole sky with this 102 colors, you can construct a whole sky three-dimensional map of the cosmic web, and that's really what we want to do.
And how does SPHEREx use color when mapping?
Right. So we will use to make this map. We will use what we would like to use rainbow colored glasses, and so you can think when you use rainbow glasses, what's very interesting about it is that the color you see slightly is different depending on exactly where you look at. And so you could say that SPHEREx will use some kind of astronomical grade rainbow glasses that we put in front of our detectors. And so it means that each part of our detectors will see slightly different colors. And so by planning a very careful sequence of pictures, of exposures, we can really reconstruct all sky map in 102 colors. And that's really what we will do is that how we will get these 102 colors that we need to make this map, this three-dimensional map of the cosmic web.
Great. Thank you so much for your insight, Olivier.
My pleasure. Yeah.
So we are actually now heading back to Hawthorne, California for an update.
Thanks, Raquel. We are just about a minute away from SPHEREx coming up here. We're T plus 51 minutes into NASA's SPHEREx and Punch missions from Vandenberg Space Force Base. About 9 minutes ago, we watched SPHEREx separate from the Falcon 9 second stage, and the SPHEREx team then confirmed and we did not confirm acquisition of signal just yet. We will confirm that at the next opportunity.
But now it's Punch's turn.
Yeah.
So they're going to deploy in 2 batches, right? So the first 2 are going to deploy around T plus 52 minutes and 16 seconds. So that's about 45 seconds from now. And then the other at T plus 53:07. Again, some great views that we're seeing here from the second stage, looking down on Earth, carrying 4 Punch spacecraft.
And as you talked about those 4 Punch spacecraft deploying in 2 sets, one of the reasons we are doing that is to separate the sets so that we can get them started on their way and make sure they're heading in the right directions and avoid the second stage and anything else that might be in the path. So keeping Punch to make sure everything is successful. Deploy 1 set and deploy a second set a few seconds later. That will help everything with deployment tonight and call this mission to an end, getting Punch on its way for its science.
2 separation confirmed.
Wow, look at that. To actually see them, that's great.
And we heard that call out, and
that is amazing. Yeah.
Punch drifting away from the Falcon 9 second stage. That is the first of 2 payload deployments, and we are expecting the next one coming up in just about 30 seconds or so.
Yeah, I'll tell you, seeing that that was just as incredible as seeing SPHEREx separate those 2 satellites separating, and then the next 2 coming up, getting that constellation out there so Punch can do their science. That's very important, and I know the Punch team is looking forward to that.
Yeah, and we are deploying these in a bit of a different orientation from SPHEREx. We did see SPHEREx drift away very slowly from the second stage, and these Punch payloads are going in a different direction. So,
Wi-Fi 1 and 3 separation confirmed.
Look at that. That is amazing. That is just
incredible.
amazing.
Yeah, the second batch right there. It is really cool to see. And again, I just know that the spacecraft teams really appreciate this opportunity to see this happen in real time. So what an incredible, incredible view. All right, so the Punch team is going to have to wait a bit longer to confirm their acquisition of signal for both sets of spacecraft. Mick, can you talk to us about when they expect to be able to confirm signals?
Yeah, the Punch team will have to wait about 30 minutes, Megan, to acquire signal from one of the spacecraft. Now that we have separated them successfully and things look great, this will help to confirm the signal for all 4. Or they'll hope to confirm the signal to all 4 satellites within an hour after separation today. So a little bit more time for the Punch team to verify everything is good, but it was awesome to see separation tonight and Punch on its way.
Yeah, it's again important to mention that, again, 4 separate spacecraft. We will have to acquire signal with each of those spacecraft, but again, they're hoping to acquire signal with all of those four spacecraft. That's a tongue twister. 4 spacecraft within an hour from now, which is when we just separated. So we will not be able to cover that live for you guys, but we will be updating our social media, and you can also check out blogs.nasa.gov/punch.
Yeah, and these views have been so incredible. It has been such an exciting mission so far. And this really is just the beginning of the journey for SPHEREx and for Punch. I know we've been live for about 55 minutes with this mission, but this is the beginning of the journey, of a very long journey for both missions.
Both spacecraft doing some great science, as we've heard throughout the show. with the mapping of our universe and the solar wind studies and all. And I got to tell you, looking at the shots on the screen, I'm kind of thankful to Farah and the team for the sun avoidance requirement, because we are seeing some great views of Earth from our second stage here, and as we have deployed these satellites. It's just amazing to see these live views from space, as you mentioned earlier, Jesse.
Yeah, and like you just mentioned, sometimes we get a lot of sun glare into the camera on the second stage vehicle, but because we are avoiding the sun, just like you said, we have some epic views of Earth there. They look so clear. It's incredible. What am I trying to say? Like the pixels that we can get from being so far away from Earth. It is just incredible.
Yeah. And again, if you're just joining us, you're listening to me, Megan Cruz, and this is Jesse from SpaceX, who was just chatting, and then the only guy on here, so you know when he's talking, that's Mick Waltman, also from NASA. And the three of us are at Hawthorne, and we're commentating through some of the incredible views that we're seeing from space right now. You know, a couple of minutes ago, we saw the SPHEREx spacecraft deploy from the second stage, and then a few minutes after that, we saw in two batches all four Punch spacecraft also deploy. So it's been really great being able to commentate through this and be able to share this with the public. But for now, let's send it back to Raquel and Farah.
Well, thank you for that update, Megan, Mick, and Jesse. So tonight, NASA's Launch Services Program has successfully launched SPHEREx and Punch. Joining us now is tonight's Assistant Launch Manager for NASA's Launch Services Program, Tim Dunn. Tim, another successful launch for NASA's Launch Services Program. How are you feeling in this moment?
Well, Raquel, I'm feeling incredibly.
Bem, então já terminamos aqui então a nossa cobertura da missão Launch Punch da NASA junto com a SpaceX. Então, eu espero a todos que tenham gostado desta transmissão. Estamos aqui encerrando aqui a nossa transmissão de hoje. Então, nos vemos aí numa próxima oportunidade. E não se esqueça de estar se inscrevendo no canal, comentar e compartilhar.